4 is lines in the plane. This is where we review a lot of the Algebra 1 concepts, slope, slope-intercept, point slope, all this stuff, okay? Parallel, perpendicular, we'll talk about that. So, slope. What do you guys remember about slope?
Y equals x plus b.
Okay, slope-intercept form is y equals mx plus b. What about just slope?
It's isn't it the spot where like they meet or something? I don't know.
I don't like it. Graph and
So, how do we graph slope? How do we find slope?
Oh, it's like you go up one, then over two. It's like the how often the lines move. Okay.
Okay. So one of the phrase, and I don't know why it's not on here. I didn't think to put on here, and I just retyped these notes too. But can we say rise over run?
Yeah.
Yeah. Okay. Slope of a line, rise over run. That's when we're graphing it. That's what we think of most. If we're given two ordered pairs for slope, x1, y1, x2, y2, this is where we tend to do y2 minus y1 over x2 minus x1, right? So you'll notice here also, first of all, I used m to represent slope. That's our common representation. Are you familiar with this triangle sign? Okay. It is delta, and it means change. Might come up, I'm trying to think, you guys use it in chemistry maybe?
Yeah.
I'm thinking that's someplace it comes up in a science class. But this is delta y over delta x, which all that's saying when you see that little triangle and it's delta, change in y over change in x. So that means I'm going to subtract my y variables over subtracting my x variables. So somewhere I know it pops up in science class.
Who else used it?
So, okay, let's find a couple of quick slopes. If you're just given ordered pairs, -1, 2, and 4, -2, how am I finding slope? Here's my help. M equals
-2 minus 2 over 4 minus negative.
Okay, does that work? You said -2 minus 2 over 4 minus -1. Remember, in an ordered pair, it's xy, xy. So he did y minus y over x minus x, right? Since he picked -2 as his first y and did -2 minus 2, then on bottom he had to start with 4. Correct? Okay, clean it up. What do we have here?
-4.
-4/5. Tough stuff there, I know. Okay, what about B?
4 minus 1 over 2 minus 1.
Y minus y over x minus x. We're going to end up with 3 over 2. Remember, for slope, we generally leave them in fraction form. We don't usually go decimals there. Not that I'd count it wrong necessarily, but okay. This next section we have forms of equations of lines. General form, honestly, oh no. Man, oh man.
What's happening?
Oh, I typed it wrong. What this, and I just retyped these notes this year, so I'm going to be finding my own typos here. What this should say is standard form. Okay? That should not say general form, but standard form, which is a form you're familiar with. AX plus BY equals C. We've used that a little bit. It's probably the form we use the least. But standard form, AX plus BY equals C. Slope-intercept form, already been mentioned, y equals mx plus b, where m is slope and b is the y-intercept. Point slope form. We use that more than we used to. Y minus y1 equals m times x minus x1. That's helpful when you have a point and a slope. You can identify them. Vertical lines are always x equals a number. Horizontal lines are always y equals a number. And the other one that's not listed here that I meant to list is something called general form. Now, I'm listing it because it's in the book, but I'll be honest. General form is not one we usually see very much. But ax plus by plus c equals 0 is general form. And again, it's probably the one that you see or use the least, if you ever even use it, honestly. We sometimes see it, but we don't really ever use it for anything. Okay, let's look at example 2 here. Use the point slope form to find an equation of the line that passes through the point -3, -4, and has slope 2. Thoughts?
Y minus -4 equals m times x minus -3.
Partially there.
Oh wait, the m is 2 because m is slope.
Okay, so point slope form, if I write that first, is y minus y1 equals m times x minus x1. Slope is 2, which is m, and then ordered pair is x1, y1, isn't it? So if you fill those in, y minus the y coordinate, y minus -4, equals 2 times x minus -3 for your x's. I don't know that I necessarily count this wrong, but can we clean it up in the mid? We don't usually leave it like this. We would really write this as what? Okay. The advantage of point slope form. If I'm given nothing else at all and I'm given this equation here, I automatically know the slope is 2 and that there's an ordered pair -3, -4 there because we use the opposite signs. So that's the advantage you have of something like that. Okay, got it?
Would I be wrong if I left it y plus 4 equals 2x plus 6?
Technically, yes, because if they want point slope form, it's m times x minus x1. I mean, it's really close, I get it, but if they say point slope form, you're not distributing that, as tempting as it is. Okay. My example 3 is on my next screen. Write an equation of the line with slope 3 that passes through the point -1, 6 using slope-intercept form. Thoughts on what to do? Okay. I'm actually going to show you 2 ways we can do this. So slope-intercept form is y equals mx plus b. She says we're going to use that. What do we know? Okay. We're given an ordered pair here, aren't we? So anytime you're given an ordered pair, you're given an x and a y. And we have an x and y in the equation. Yes, we can fill those in. What else do I know? Slope is 3, so m. So fill that information in. 6 equals 3 times -1 plus b. What's this going to allow me to do? Find b. So do some math. 6 equals -3 plus b. If I add 3 over, then I know that b is 9, yes? So b is 9. Slope is 3. Do you have the information to write your equation now?
Yeah.
Yeah. You have the information to write that this equation is y equals 3x plus 9. There's another way to do that same problem. You guys know?
No.
Okay. It says use the point, no, write an equation of the line with slope and passes through this point. I guess it does say using slope-intercept form, doesn't it? So I guess if I want to be technical with those directions using slope-intercept form, there's a way you could start with point slope and get to slope-intercept form. And there are definitely times I like that, but now that I reread that, it says using slope-intercept form. If your goal is to just end at slope-intercept form, you could start with point slope. Remember point slope that we just talked about? Y minus y1 equals m times x minus x1. If you fill that in, y minus 6 equals 3 times x minus negative 1. Could you manipulate this to get to y equals 3x plus 9? You can. And there's times I definitely like that a little bit better. Because if I distribute, y minus 6 equals 3x plus 3. And then I can add 6 over. And y equals 3x plus 9. Okay. You'll see me do that at times. Just because I like the flow a little bit better than I do this. But they're both good methods. Nothing wrong with either of them. Okay. Trying to decide how I want to do this. We have 10 minutes left. Okay, I'm going to skip around here and try something a little bit different. So, example 4 is drawing a graph of that equation using the graphing calculator. I can do that, and then I'm not going to get to parallel and perpendicular. Or I can do parallel and perpendicular, and I can teach the graphing tomorrow. I think I'm going to prefer that, because then I know some of the graphing and homework we need help with anyways. So we may not use the graphing calculators as much as I thought we would today. Sorry. Tomorrow we definitely will. So we'll come back to this. Let's talk parallel and perpendicular. Do you remember parallel and perpendicular lines? Parallel lines like this. What do we know about parallel lines? Or this.
They never touch.
Never touch. Never touch, never intersect, never cross.
Never end.
What's important about them? They have the same slope. Okay? What's perpendicular mean? They cross how?
Middle.
Not necessarily middle. At what angle?
90.
90 degree, yes. Perpendicular lines cross at a 90 degree angle. What do we know about their slopes?
The same. Opposite. Yep.
Opposite reciprocals. What do I mean by opposite reciprocals?
Like, this one is like positive, but this one down here would be negative.
And? So opposite is positive versus negative.
Would it be like 3 over 2, then the reciprocal would be 2 over 3?
Yeah. So if I say what's the opposite reciprocal of 2/3, the opposite of positive is negative. The reciprocal of 2 over 3 is 3 over 2. Yes? Okay. Example 5. Find an equation of the line through, that's P is in point P, 1 comma negative 2, that is parallel to the line L, which has the equation 3x minus 2y equals 1. Okay. So we want a line that is parallel to the given line. What do you need to write the equation of a line? We need an x and a y, which we have, yes. What else do I need?
A slope.
A slope. Do I have a slope? No. How do I get a slope?
Use the equation.
Use the equation. So 3x minus 2y equals 1. What do we want to do to that to find the slope? Yeah, can we turn that into y equals mx plus b? Yeah. So let's turn this in. So basically solve for y. If I want to solve for y, let's see. I'm going to subtract 3x. You can do this either way. So then I have negative 2y equals And I'm going to reverse mine and say negative 3x plus 1. And I did that just because in my brain, I know I'm going for y equals mx plus b. So I'm trying to get myself ready. How do I get y by itself? And when we divide by negative 2, we're going to divide everybody by negative 2. What's this become now? Negative 2y divided by negative 2 leaves me with y. Negative 3x divided by negative 2. And what is a negative divided by negative? Positive. So I'm going to say 3/2 x. Although, well, I'll leave it as that. And then plus 1 divided by negative 2 is really a minus 1/2. I didn't write that in great form, but what do we know? What do we know? What? Denominators are the same. Do we know a slope?
Negative. Or 3/2.
Yeah. If I had written this better and written as 3/2 x, which is what I probably should have done, we'd be able to see that our slope is 3/2 because what form are we in? Yeah. The whole point of getting that to y equals is that we have y equals mx plus b. So now we have a slope. We were given a point. Can we write the equation of a line parallel?
Yes.
What do we know about parallel lines?
They have the same slope.
They have the same slope. So what slope am I going to use? 3/2. So it just says find an equation of the line, doesn't it? It technically doesn't specify how or what form to end in. I will say we usually end in slope-intercept form. But this is where I like to use my point-slope form and then end in slope-intercept form. So if I'm using point-slope, think y minus y1 equals m times x minus x1. Y minus what? Negative 2 equals m 3/2 times x minus 1.
Yes.
Okay. If I clean this up a little bit, y minus negative 2 is y plus 2. If I take the 3/2 and distribute, we have 3/2 times x is 3/2 x, minus 3/2 times 1 is 3/2. If we're going for slope-intercept form, what else do I need to do? Yeah. We want y by itself, subtract the 2 over. So y equals 3/2 x. It's minus 3/2 minus 2. What?
1/2.
No.
5/2. Negative 5. Minus.
I'm going to go with the
Oh.
7/2.
Because you have to multiply by 2 should be have the same denominator.
Mm-hmm.
So negative 3 minus.
If you're thinking negative 3/2 minus what is 2 as a fraction, it's going to have to be 2 over 1, which is then 4/2, right? Negative 3 minus 4 is then going to make it minus 7/2. Or I'll be honest, my brain will sometimes shortcut and say, oh, that's minus 1/2 minus 2, which is minus 3/2. Minus 3/2 is 7/2. Okay? Now, directions didn't state in this case slope-intercept form, but I think that's where we'd end up. I still didn't get through perpendicular. Well, good. Okay. What's the difference with perpendicular?
Reciprocal slope.
Reciprocal, yes? So once you get your slope, you'll have to do opposite reciprocal. Can you find the slope of this line real quick?
Probably.
What's the slope of this line?
About 4.
Now, is it y equals? Yeah. So if we rewrite this and subtract it over, it's going to be negative 4x plus 3, yes? So the slope of this line is negative 4. What is the opposite reciprocal? The opposite of negative is positive. The reciprocal of 4 is what? 1/4. So here's the deal, guys. In order to do this problem, you're going to use 1/4 and 2 negative 3. That's doable, right? You just have to know to use the opposite reciprocal. I'm going to tell you the answer. That way, if you want to work it, you can. Ends up being 1/4 x minus 7/2. Now, here's what I want you guys to do. Go through the homework. Don't worry about the graphing ones. We'll talk about graphing calculator tomorrow. But other than that, I think you're good to go on everything then. Except maybe 45 we'll have to talk about. Okay? So 27 through 30 are graphing. We'll talk about those tomorrow. Okay? 45 goes with this last one. You can look at it, but we'll also talk about it tomorrow. Do the others. Sound good? You guys are always welcome to grab the graphing calculator when you walk into class.